I am Anirban Rai. I'm going to be taking your live sessions. I am from IIT Delhi, but this course is offered by IIT Roper, as you know. So first of all, we have to get into what are your expectation from the course, or what do you expect to learn? How how am I? How can I possibly help you there?
Oh,
Yes,
sir, this is Pragya. Uh,
yes, ma'am.
I'm I enrolled this course for coursework for PhD work. So even I was also trying to search how some like the forum like this to whom I can ask what is the question pattern and how to prepare for the exam certification exam. Uh,
Okay,
that kind.
okay, very nice. Someone
Uh,
else, and like, what are your background? So you're doing PhD, right?
Yeah, computer science in background.
Okay,
If you explain what is the question pattern and how to prepare for the exam, and is there any practical, so that will be beneficial for us because I am very new to this platform, and passing out this exam is very crucial to uh, like get my PhD license. Yeah.
okay. Anyone else? Trying to get my iPad started, but having
Yes, sir. I'm Kiran.
nice to meet you, Kiran.
Nice. Thank you, sir. Uh, uh, so, so in the lecture series, so I covered the week one lectures,
Okay,
and uh, so I need some uh, solving the mathematical equations that are present in the video lectures
okay,
uh, to gain a better understanding to solve the quizzes that are given in each and every week.
okay.
So that's it from my side, sir.
Okay, thank you very much. You are doing PhD as well, or
Completed PhD, sir.
okay, okay, very nice. Anybody else?
Good evening, sir.
Good evening, Krishna. Krishna, you want to say something?
No, sir.
No, like
I'm not speaking anything. But after like conversation about the classes, then I will speak.
okay, okay. So what are your goals here through this online course?
It is actually I am doing for my PhD coursework.
Okay.
Yes, sir.
So for PhD coursework, this nptel course is required.
Yes, sir.
Okay, okay. And anybody else?
Hello, sir.
Yes, thank you.
I am
Harshit.
Harshit.
Hello, Harshit.
Sir, so currently I am in third year of my BTech.
Okay,
So I am from Delhi itself. I am doing my BTech from Delhi University. So I have joined this course and I have completed the week one course material, and I was able to solve the assignment problems. My expectation from this live session is uh, some the problem which are given in assignments are more case study based types. So I will be happy if you give some questions so we can understand the approach to solve those case studies type problems.
Okay, okay, okay. So those type of
And
case
the
studies
course,
type of problems are in Kaggle. You know, Kaggle is a popular machine learning site to solve problems there. So that type of problems are there in Kaggle. You can pick problems from there, and I can also give you as well. Yes.
okay, okay. And can we ask some doubts that we have related to the material that we are taught? For example, in some modules, I have some confusion. So
Okay.
I want you to directly ask the question about that topic. Not you don't need to cover the entire topic, but I have some confusion. So sir explained it, and I didn't catch up the
Okay.
that point. So I want to ask some questions as
Sure.
well.
Sure. Sure. Yes.
Okay. So
Okay. Anybody else want to give the introduction, expectation from the course?
I have a query. Would you be conducting this session on Saturday or on Friday?
On Friday itself. Just this one got postponed, but otherwise it will be on Saturday only every week.
Saturday or Friday? You said Saturday
I
just
said
now.
Saturday. So it will be Friday. Friday. I'm sorry.
Friday 6 to 8.
Yes, Friday 6 to 8. Yes.
All right. Yeah. Thanks.
Having some issues here. Link is not accessible. Please record the session. So I'm recording. I think yes. And anybody else like anything, anyone other than PhD who are trying to do a PhD or have done a PhD? How many people are there? 38.
Sir, one more question, sir.
Yes.
So, can you implement these concepts in any framework
Yeah, yeah, you
and
can.
show the demonstration?
Uh, I should be showing the demonstration. Okay, I'll try that. Yes, yes, I can do that.
Okay, sir.
Anybody else? I'm having some issues connecting with my iPad. Let's see what I can do. Pushpa Mani, you say something? So, how many people have like experience in machine learning or have learned machine learning before coming to this course?
Yeah, I learned it in my ME.
Okay, okay, okay. Uh, so usually in deep learning, so the topics we are going to cover. So let's see about that. You can see this, right? I'm presenting. I'm not presenting. I think. Mm. So some history of deep learning, and then multi-layer perceptron. So the main thing will be this one: feed forward neural network and backpropagation. The backpropagation algorithm is the way to train these models, and then these are different optimizers. Okay, so we're learning about optimizers here. Okay, I think I was able to. And hmm. Okay, so the optimizers, this is a machine learning concept, principal component analysis, but we will learn this so that the autoencoders, which are uh, made using deep learning, we will compare it to a principal component analysis. It's very simple, similar to principal component analysis. Basically, what happens in autoencoders means principal component analysis gives one solution of the solution that autoencoders provide. So autoencoder provides multiple solutions. Okay, so principal component analysis provides one of them. So that was just some comparison that is required here. And then regularization. So deep learning models tend to overfit the data set, training data set, but fail to generalize to test data set. So one of the ways to overcome that is regularization. And then some NLP based things here, and some CNNs, which are basically used mostly in vision problems. Okay, some other advanced architectures here. And are you able to hear what I'm saying? Finally, finishing with some advanced topics on week 12. uh, am I audible? Where am I? Any response? Hello, did you listen to what I said about the course structure? I think.
No, no, you were removed from the meeting.
Oh, okay, okay. So let me see. Okay, okay, okay. Mm.
Good evening, sir.
Yes. Just 1 minute. What is switching?
Okay, sir. Sorry.
Okay, it is switching. I have to join in both of them. Open. I don't need to switch. So it went wrong actually. So I was trying to. So okay. So I was trying to join from both the device, the laptop and the Mac. What do you call it, iPad both. But I switched, I think. Uh, so what was I saying? Here, na? Okay. So what was I saying is that the course content actually. I was saying that. So the week one is the history and some basics like what is perceptrons. Okay. And then we go get to real deep learning. What is multi-layer perceptron? Feed forward neural network. The algorithm to train. Am I audible now?
Yes, perfect, sir.
Yes. Okay. Now the algorithm to train the this deep networks is called back propagation. Okay, so this is one of the most important content, week 3. And now making the model converge, okay, with the algorithm is an optimization problem. Okay, so these are the different optimizers.
So sorry to disturb. Are
Okay.
you sharing screen?
Yes,
Because I cannot see.
you cannot see.
No, is everyone is able to see?
um,
Yes, sir, your skin is visible.
Visible.
Okay. Okay,
clearly visible.
maybe some problem in my side. Okay.
Maybe yes.
Sir, your voice, screen, everything is perfect. We can continue.
Okay, so since we are discussing the optimizers, so suppose I'm using okay, can you stop the okay now so these are the optimizers here, and so this is up to week 4. Then we learn about principal component analysis and its interpretation. Okay, so autoencoders are like the deep network form of principal component analysis. Principal component analysis is like it gives one solution to the autoencoders. Autoencoders provide multiple solutions. Okay, so these are the relations. It is for all are used for dimensionality reduction. Okay, now different now this deep learning models tends to overfit on the training data, and fail to generalize to the test data set. So that is called overfitting, and one of the way to mitigate it is regularization. So week 7 we focus on regularization and any other method to not make the model overfit and improve its generalizability to the test data set. Now some other methods for improving the trainability of the deep networks. So this you can see, and next we go to the language modeling part. Okay, so the representation of words, some representation learning problem of the words. So you need some vector representation so the models can understand the words. The words cannot be interpreted by the machine learning model, so you need some interpretation or representation of the word. So that is done in this week 9. Next we go to some vision type problems using convolution neural networks, as you can see, and week 11 week 12 covers some uh, more advanced concepts. Okay, so like recurrent neural network and some important aspects like attention mechanism, those things. Okay, so everybody could hear what I said.
Yes, yes.
Yes, sir.
Okay, okay. So now I try to join from my iPad without removing myself from the laptop. Just wait a minute. So maybe we can continue with the introduction, and some people have not joined. Okay, 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 okay. So, so anybody is like a bachelor student here? Okay, many people. Okay. So like, what are your expectation here now in the day of AI, in the age of AI? What are you trying to achieve from this course? Someone wants to introduce themselves and answer this.
May I, sir?
1 minute, 1 minute. Just
Okay.
okay. Now it's fine. No echo here. No.
Hello.
Okay. Oh yeah. Yes.
Hi, sir. May I introduce myself, if you don't mind? Hi, guys. My name is Heath, and I'm currently pursuing my last year of bachelor's. Maybe little too late for joining NPtel in graduate time, but I'm looking forward for guidance in my career path. So everyone was making so much boom of AI, but I didn't know what was it true, and what's the true worth of it in next few years. So I'm going on basics and fundamentals. So I have joined this IIT Roper's class of deep learning, and I hope that maybe if someone has any other suggestion, or sir, if you have other suggestion
Hmm.
to join another class as well, then it's been appreciated.
Okay. So there is a machine learning course running as well. So you can join in there. So machine learning with Balaraman Ravindran and few others are there as well. If you want to uh, deep dive into machine learning as well. But like current models all use deep learning models. So if you want to skip machine learning, that's okay in a way.
Maybe I'll go for a machine learning because my basics are not good enough.
Hmm.
So two classes per semester is good, right?
Yeah, if you can manage, both of these are not so easy course. So you can see that.
Okay, I'll try hard, but let's hope.
Uh, so anybody else? I'm still struggling to.
Hello, sir. Am I audible? My name is Suman.
Nice to meet you, Suman.
Yeah, so I am actually a seasoned professional. I have around 25 years of IT experience. Currently, I am doing my PhD along with my work, and this is actually part of my coursework material. So I just wanted to understand one thing, sir. Uh,
Yes.
See, is it this set of assignment problems? Because one of my major reason for taking deep learning is that for the research stuff. So is the set of questions whatever is coming in assignment, those same set of questions will be coming in the exam? Because I would be writing NPTEL for the first time in my life, so I have never
Yes.
written it.
Very, very similar questions.
Okay, sir. Thank you so much.
Sir, exam will be in pen and paper or lab based?
Uh,
Like you,
it will be online actually. Not pen and paper based.
sir, question pattern, it's fully objective type, or we have to write the program, need to get the output, or how?
Mostly objective. I think 100% objective.
Okay. So it's good if you explain us like the exam pattern so that we can prepare. We are very new to this.
Exams are far away now. Nothing to worry for now.
Okay.
Hmm. Anyone else wants to say something? Ayushi Chanda, want to say something? Ayushi. Yes. We'll be starting now. But I couldn't join from the iPad for today. So let's do it here only. also I'm presenting already. And so do some basic warm-up questions from the week 0 assignment, which might be very easy for some of you. Little brush up on maths and probability. So, so this is what we have here, and so the first question: anything and has anybody has any doubt about like the course or like their background, what background they may need to do this course or something like this before we start? Am I audible?
Yes, sir. You are audible, sir.
Okay, okay. Anybody has anything to say before we start?
So this is a problematic paper, sir.
This is the week 0.
Can you introduce yourself, sir?
Can I?
Can you introduce yourself, sir?
Okay, sure. I'm Anirban Rai. I'm a PhD student in School of AI, IIT Delhi, and I am a PMRF scholar. So for that, I need to do TA for this course. Okay, and information is not clearly visible. Okay, we'll get into this problem. So this is my introduction. My research problem is using AI models. Specifically, I use world model for molecular generation, simulation, or folding task. Okay, so this is my work, and this is it. Okay, thank you very much. Anybody else? Ayush, you're raising hand for a long time. You want to say something or like?
Okay, thank you, sir, for introduction.
Thanks.
Thank you.
And okay, so let's get started now. This is not good visible. If I do it, can I write here? Not able to write. Is it visible? Can you see what is written here?
No, sir.
Yes, sir.
It is not.
Now it is correct. Okay,
No,
sir.
sir. It is side.
Okay,
It should come center, sir.
okay. Bring to the center.
No, sir. It is in left side. So yeah, it's fully on left side of my page, sir.
Okay, so maybe I can remove this one.
Only prime number, second matrix, first matrix, and the same number of columns, the second matrix is visible, sir.
Second number. Okay, so you're not getting to see it.
Yes, sir.
Then how can I?
Sir, it's visible.
It's perfectly fine for most of us, I guess.
Okay, sir. Now it's okay, sir.
It's okay now.
Now it is. Yes, sir.
Is it smaller for others?
Yes, sir, smaller, sir, but the information is not clear.
It's not visible.
The information is not clear, sir. Letters are not visible for me.
Okay.
Just zoom it, sir.
Zoom.
What, what the question you are given is not yet clear.
If I zoom.
Zoom, you can go for, sir. Yeah, 75. Oh, no, it is
Okay,
more
it's
now.
cutting out.
Yeah, yes, sir, it's cutting.
I think
Sir,
it's
just copy the text, then you can just increase the font of it. If you'll just, yeah, through the NPTL page, just copy the text. and not the whole question as a image.
I think that's not a good idea. Then it will not come out well. But if you say I tried, I had already slides prepared, but maybe I'll just email those one. Could not log in from the. Just wait a minute. Uh, why is it not coming? What a problem. It's not working so well as well. Let's get back to that one. Okay, perfect now.
Yes, sir. Perfect.
Okay.
Yes, sir.
Okay. So we're going to do this. Okay. Now what we have here is so transpose of the product of two matrices is equal to product of the transpose of the two matrices in reverse order. Okay, so let's see how can I write here. Next, so easy with the iPad, but I don't have today.
Sir, OneNote also you can use, no? That is also like writing in pen and paper. OneNote. Uh,
But if I can do it here, that's better.
okay.
Shape text, media, music videos, comment, charts, tables. Any writing, just want to write like simple. Can I do that? Anybody's an idea? iPad is creating a lot of problem today.
Maybe I suggest that you just type it out on the text thing.
I can do that, but won't be as good. Okay, whatever. Try this. So the transpose the product of two matrices to the product of the. Okay. So what it tells is equals to
Maybe it will be too hard for you. You can try it out.
uh,
Whether paint or something.
so this is the formula of transpose. So that is correct, right? So this one is correct. Uh, and to the next question. Uh, Next question. So the number of columns of the first matrix must be. So it is a question about matrix multiplication, and so matrix multiplication means that obviously hard here. So A multiplied B. See if I can do something with the iPad.
Maybe you can check in the shape tool if there is a draw option.
It will be hard, I think. Just the geometrical shape, not free flowing writing. Work maybe no. So this is the matrix multiplication. This will be hard, yeah. We could configure it. Okay. Can you restart this device?
Sir, or you can use Microsoft PowerPoint.
This is a Mac device. I don't have that. Um,
Maybe sir, online version of it also offers that facility.
yeah, just wait a minute. So we can do it orally. Third question we can do it orally, or with little bit of writing. So if a dice is thrown, what is probably the number obtained is a prime number. So if a dice is thrown, the number of possibilities are 1, 2, 3, 4, 5, and 6, right? And now how many of them are prime number? So that is 2, 3, and 5, right? So three possibilities, that is a prime number.
1/2 is the answer.
Yes. So
Second question, both S1 and S2 are true, no sir?
yes, now I've got access to the this one iPad, and I will be able to show you now. Mm. So I'm going to present from the iPad now. Just a minute. Now it is going to be easy. Okay. So stop presenting here, and so what I'm going to do. Um, so am I presenting from here? So I'll present from here. Okay. Hmm. And so I've started presenting from here, and you can see, right? So now it will be easy for me. So now, okay. So the thing is, it will cut off, right? Not visible. Okay. I can play here, right? Visible now? No, sir. Not presenting at all. I am presenting. Okay. So you have to use another screen actually there. Uh, from
Sir,
landscape.
should we try landscape mode?
Okay. Okay.
Sir,
Yes.
sir,
Yes. 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 Correct. From landscape mode, and now visible.
sir, in the options, so go to
It's correct,
the
sir.
adjust view.
Now it's visible too. Perfect.
Perfect, right? Okay. Okay.
Yes, sir, perfect.
Do one more thing, sir. Do one more thing. So it is right better. So go to the options and see the adjust view option.
Okay, that's it.
Google Meet settings.
Adjust view option on this I rotated. Uh, adjust view option. Okay, is there something there? Admit three guests here. So do that first. No, got rotated. Oh my god, disaster.
Adjust view and use the slide bar, sir. Then
Okay.
you get more space to present the window.
Let's focus from here. Can you see the question number four here?
So it is visible, but the letters are too small.
It is small.
Yes,
Okay.
sir.
So what can I do? Can I use
Little bit
highlighter?
zoom it, sir. Yeah,
No,
perfect.
no, now it's good.
Sir, it's perfect. Sir, it's perfect. We can go ahead now.
Okay. So what is the probability of getting a queen of club or a king of heart? So this is this question. So we have 13. So
Sir,
13.
zoom it, sir. Some more. So questions are very tiny. We can't understand what the question is there.
Okay. More zoom.
Sir, please zoom it some more.
Question is already on Swam portal.
It's already there in the assignment zero. I think everybody can open the assignment zero.
Uh, just let it pass through then. Okay. Otherwise, we won't cover anything. Okay. So
Okay, sir, go ahead.
okay. So there are 13 clubs and so these are the okay. So there are four types of cards first of all, and there are 13 of them. Okay, each, and in each of them there is one queen, one king, one jack, and another one ace. Okay, so what is so queen of clubs? So club is one type of card. Okay, and heart is another type of card. Okay, so 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 what is the probability that either of them comes? Okay, so in so queen of club is only one card. Okay, and king of heart is only one card, so there are two total possibilities, and the total number of cards is 52, of course. So we get the answer 1 by 26. So very easy, right? Without the slides issue and those things are quite easy. Okay, so the probability that it will rain tomorrow is 0.85. What is the probability that it will not rain? It's a very simple question. Okay, so it has to be this one, right? It is the exact opposite situation, that it will not rain. Okay, so it is 0.15. Okay, 15 by 100, so that is
None of the answers are matching, I think, sir. In fifth question.
uh let me see. So this will become 3 by 20, right? So this one is matching, right?
Okay, okay, sir.
Is it really poorly visible now, or okay? Okay, so let's continue. So the
Yeah,
answer
explain fifth question one more time. Fifth question.
Okay, I explained again. So
Yeah,
it's very
please.
simple actually. So probability that it will rain tomorrow is 0.85. So the 85% chance that it will rain tomorrow. Now they have asked what is the probability that it will not rain. Okay, the total probability is only one, always one. Okay, 100%. Okay, so 85% of it tells that it will rain tomorrow. Then 15% of it is that it may not rain tomorrow. So probability that it will not rain is 0.15 or 15%. Okay, so 15% you can write it as 3 by 20. Okay, understood?
Yes, sir. Yes, sir.
Okay. So now they've asked the eigenvalues are given. Okay, and this, eigenvalues are given. Okay, so these are 2, minus 3, 13, and 7. What is the determinant of A? Now our way to approach this problem. So the fact is that the product of eigenvalues is the determinant. Okay, the determinant will be negative here, but they haven't given that. It is minus 546. Actually, the answer is, you can multiply. Okay, so how do we get that is the question. Um, okay. Hmm. So how do we get that the determinant is minus 540? Why the determinant is the product of the eigenvalues? Okay. So how do you do that? Is if you take any matrix of any dimension. Okay. So say that this is a00, a01, a0 n. Okay, or n minus 1, let's say. You can see, right? And then a10 a n minus 10. Okay, so like that is the matrix. You can understand this will be a1 1. Okay, like that a12. Okay, a11 a12 okay. So this is the matrix we have. Okay, and now so how do you find eigenvalues? You multiply, you let that lambda is the eigenvalue, and you subtract lambda from the all the diagonal values. This is a n minus 1 n minus 1 minus lambda. Okay, now what you do, you multiply it. Okay, means you take the determinant of it, put that equals to 0. Okay, now what happens is that these will be multiplied, right? I mean, you have to calculate it like this: a0 minus lambda a00. I mean, okay, let's see. And this will become determinant of smaller version of it. Okay, so you can write it like a11 minus lambda, and like that. Okay, and okay, then minus. So after doing all this exercise, what you get is a equation in which there is it is of the form like lambda to the power n c plus c1 c0 c1 lambda to the power n minus 1 dot, and finally c0. So you get that c0 after comparing a polynomial of this form with the form you get here. You get that c0 is equals to multiplication uh, of the eigenvalues, and there you get the formula. So I think this is called Cayley-Hamilton equation, something like that. It was the name, and from it you get the idea that this is product of the eigenvalues. Okay, there's some other ways as well. Okay, now moving on to the next bunch of questions.
But C0 is the coefficient of lambda to the power n, right?
Acha, C1 I have written,
C0,
right? So
C0 you have written, so
yeah,
that will be constant term. That is your determinant.
the writing is already removed. Okay.
Okay,
So
sir. You have written C0 lambda to the power n. That's why I'm saying.
yeah, so it you can write it Cn. That is better
Yeah.
notation. C n
Okay.
minus 1 lambda n. Okay.
Okay, sir.
So so this is a very basic question. Sum of two numbers is 12, so you can take them as x and 12 minus x.
Can you zoom it sir, a little bit?
Not able to see. This is better, or
No,
No, sir. The information was clear. Letters are not clear.
Letters are not
Just
clear.
zoom, sir.
Uh, how do I zoom in my phone? Uh,
Down. Perfect.
okay. So
Yes, sir. Now it is okay, sir.
so we have x and 12 minus x. Let the two number be to this. Okay. Smaller number is doubled. So let's say x is the smaller number. So it becomes 2x. Okay. And add it to the larger number. So this is a larger number. Okay. So add it to the larger number. So this becomes 12 plus x. Okay. This result is equals to 16. This is equals to 16. So x is equals to 4. Right. The smaller number is 4. Okay. So the larger number is 12 minus 4. That is equals to 8. Okay. So 4 and 8. Any doubt?
No, sir. Go ahead.
No doubt, right? So we have to find the product of these two matrix. Okay, so how do we find the product? The row by column method. Okay, row times column method. So what we do, take the first row 1 0 0, we multiply it with the first column element wise. Okay, so 1 multiplied 0, 0 multiplied 0 plus 0 multiplied 0, 0, right? Now we take the first row, the same again, 1 0 0, and multiply it with the second column. It will still come to be 0, and you keep doing it. So what you get after doing it, you get three zeros, right? You take the second column, second row. Okay,
Full zero.
second row, all three are 0, and you multiply it with the columns. Okay, this also becomes 0, right? And the final matrix, then you have to take the third row and do it again. It again becomes 0. Okay, so this becomes 0, right? And matrix multiplication is always possible. Suppose this is dimension is n cross m, this is m cross d. If these two are same, okay, then it's always possible. Okay, this third question for that as well, but okay, we'll see that. Second question, I think. Now S1, S2, S3 are statement regarding matrices. The identity matrix is always a square matrix. So that is a true statement. So identity matrix is always a square matrix, uh, and because the reason for it is first this AI. So this has to be valid, right, for any matrix. So for it to be valid, suppose this is A is m cross n. Okay, so then I needs to have one n at least. Okay, now okay, square, I guess. Yeah, it should be square. Admit the text. Okay, so in that case, another matrix is used. So this is n cross n, and this one will have be m cross m. Okay, like that, the product will be always possible. Okay, okay, so it is always a square matrix. Okay, that's a true statement. Product of a given matrix and its inverse. This has to be I, right? Always gives an identity matrix. So that is one of the definition of linear algebra. Okay, so there is nothing there actually. And product of a given matrix and identity matrix result in the original matrix. So that is also correct. Acha, in one of that question, here, so here as you can see the product will actually be negative. Okay, so they have not actually given it, so it has to be minus 546. Okay, okay, if a matrix is multiplied by a constant, okay, let's say the matrix is A, it is multiplied by a constant C, uh, and if its transpose is taken, so you need to take the transpose of it. Okay, now C is a scalar, so it has dimensionality of 1. Okay, or 1 cross 1 you can write. Okay, so transpose of a scalar will also always be a scalar, right? So if you can just so it will be like A transpose and then C transpose. So A transpose is always C, right? And you multiply, you write the scalar at front or behind, it doesn't matter. Okay, so this is the answer. The matrix obtained is equal to the transpose of the original matrix multiplied by that constant. Okay, any doubt?
It may be complex, na, sir.
What do you say?
It may be complex number, then we have to take conjugate. No.
But you have to take only a transpose, that is, it is not conjugate transpose.
Yes, sir. Yes, sir.
Okay. Now, let's go to the first one. This got rotated and unable to fix it. What a problem. So let me just remove this one. Better idea. Take another from here. Copy. So I've done that. Now is it visible? Do I need to zoom? Not a problem. So the transpose of the product of two matrices equals to product of the transpose of the two matrices in reverse order. So you have A times B. You take the transpose of it. That is equivalent. So the definition of transpose is basically uh, B
B
transpose.
transpose into A transpose.
Okay. B transpose into A transpose, right? This is definition and true, of course. Okay. S1 and S2 are two statements regarding matrix multiplication. The number of columns of the first matrix must be equal to the number of rows to the second matrix. Okay, so let's see that. So A times B we have. Suppose the dimensionality of A is m cross n, and B is so B has to be like this. These two has to be same, right? Because remember we are doing row multiplied column. Okay, so the length of the row, which is the number of columns present, right? The length of the row or the number of columns present, that is n, has to be same as the length of the column or number of row present here. Okay, let me show you again. So what we were doing, suppose this is 1 2 3 4 5 6, and we have to multiply it with 4 5 6 7 8 9. So these are the two matrices. We need to multiply these two matrices. What do you think? Is the matrix multiplication possible in this case? Okay, two more to admit here.
Yes.
So how do you say that?
Number of rows should be equal to number of columns in the second matrix. M cross n should be equal to n cross p.
Mm, so what we were doing, suppose for multiplication, what will be the result? So it will be the first element here will be 1 cross 4, 1 multiplied 4, 2 multiplied 5, and 3 multiplied 6, right? These are added together. So the number of element here 1 2 3 should be same as number of element here, otherwise multiplication should not be possible, right? So the number of elements here shows the how many is what does it show? The column length, right? Okay. Hmm. So or yes, is correct. Number of columns present. Okay. So the number of columns in the first matrix has to be same as the number of rows in the second matrix. This is our condition, right? So this has to be same. The number of columns in the second matrix can be different as the number of rows in the first matrix. Okay, M and D can be different, but these two has to be same. Okay, so this is one important thing. So the number of columns, so first statement is correct, right? Number of columns should equal to the number of rows. So S1 is true, and then result of the matrix multiplication is same number of rows as the first matrix. The result will be M cross D here. Okay, so same number of rows as the first matrix and same number of columns as the second matrix. So both are true. We're done. If a dice is thrown, what is probably the number obtained is a prime number.
Anirban, sorry to interrupt, but will you also take up this week one assignment today?
I was not planning to, but I can help you because the submission deadline is still far. So
Okay.
I wanted to
So
help you.
today is not planned, right?
I can help you if you have any doubt. I can push you towards the solution better.
Okay, okay, sure. Okay.
Have you tried it already?
Yes, yes, I was trying it. Actually, I have completed this, so I was just thinking to leave this class if you are not taking up with the week one assignment.
Okay. Do you have any doubt in week one?
No, 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 not as of now because I have completed half of it.
Okay. So if your dice is thrown, what is the probability that the number obtained is a prime number? So there are three prime numbers in. So there's 1, 2, 3, 4, 5, 6, and so number of prime. So one is neither prime nor composite. Okay. Two is prime. Three is prime. Okay. One is not. Okay. And five is prime. Right. So there are three options here. And can you automate this one? Adding this one. Can anybody join? Make my life easier. Heath, any doubt?
Yes, sir, regarding that first week's assignment,
Okay.
maybe not completely doubt, but just a question. So
Hmm.
you can continue after you finish this
This is
one.
the last question. Okay.
Okay. No,
So
no hurry, sir. All right.
so three prime numbers are there, and the total number of possibilities are six. Okay. Our probability becomes 1/2. Okay. So this one is done now. Okay. Let's get Heath's question here. Heath, you can throw your question.
Yes. So can I have a question regarding that? In the first assignment, there was a question that alarm system thing,
Yeah.
but there was one option regarding that which one's logic is correct and which one's is not. So yeah, it was multi-choice question,
Mm-hmm.
and there was one option. It was saying that house noise. It was saying that noise reduction Isolated sensor noise reduction can increase the resistance to system, like that it can increase safety, but won't it make more vulnerable?
Increasing the threshold beyond the chosen value. This is the option, right?
Yeah.
Increasing resistance to isolated. Okay, let me present from this one. Okay, so I'll shift from the iPad to this one. Okay, this MacBook. Okay, and okay, the presentation I'll shift. Any doubt on the tools here? Anybody have any idea?
No, sir. No, sir.
So sorry for the interruption. When you're going to explain the week one questions, sir,
So let me be clear. Okay. First,
after the deadline of the week one submission?
yes. Detailed solution I can provide only then, because you are supposed to solve this problem, and these are graded questions. Okay. So you'll be graded on this. Okay. So I cannot give the solution before you try. Okay.
Okay, okay. So one day request is just explain the question, what it is. That's what is enough.
Yeah.
Solution later you can give.
Yeah.
Just explain the question. The question itself we can't understand what it is.
Yeah. Understanding the question is also a task, though, but I
Yeah,
can
difficult, difficult
give
task.
you
Just
solution.
explain the question.
Yeah.
Enough.
So so let's do that. First, let me be clear here. So what my task here is to, like, not give you so much that you are the half of the question is solved, or like almost is solved. Maybe little hint is possible. Okay. Other than that, from next week I will give similar questions, but not this. Okay. So practice on the similar questions, and you can do it yourself. Okay. That I can do. Okay. Okay, let's go to the question now. So high security research facility operates multiple restricted access buildings that so equipments are there. Unauthorized entry has to be stopped. Surveillance systems required to, it should work reliably under varying environment conditions. Must minimize both intrusion, false alarm. Okay, so this is the important, just important condition here. One important sentence written here: must minimize both missed intrusion and false alarm. Okay, so what do you see here, that in machine learning, so I'm presenting here, right? So you can see the question yourself, right? From the portal. So I will actually present from here only. That's a better idea, because I can write then. Hmm. So just to just to tell you what I'm going to do, add another slide. So in machine learning problem, so we have some situation. So you can see the white page here now.
Yes, yes.
Okay. So what we have here is that when a model makes prediction, or anybody makes prediction, suppose I make a prediction. So we have four situations. These are possible. Okay. So I say that a event A has happened. Okay. So this is my predictions, and these are the truth. Okay. I say that the event has happened. So event A has happened. Okay. I say that it is true. Okay. So uh, I write it truth, and these are the predictions. Okay. About event A, I say it has happened, so it is true. Okay. And the real truth, it has. So the truth is also that, ground truth is that it has happened. Okay. So both are true. Okay. Another is that I say it has not happened. Okay. but the real thing is that it has happened. Okay, and another is the real, I say it has not happened, and the real is also it has not happened. I say it has happened, T, but it has not happened actually. So these are the four possibilities. Okay, now, so what we are doing is that, so it is surveillance system. If someone unauthorized enters, okay, if someone unauthorized enters, okay, and the alarm does not go off, okay, so unauthorized enters, so that is the event A. Okay, so if that is true, okay, but the alarm does not go off, so it does not say someone's entered, so this is the situation. Okay, okay, so this is the missed intrusion case. Okay, and this one is false alarm. So what is, it gives the prediction true, someone has entered, but there is nobody has entered actually. So this is false alarm. Okay, so each building is fitted with 4 independent binary sensors. There are sensors everywhere, so that you can, so from which you get the data to have the alarm. So door status sensors, the different sensors are there. Okay, which will combine give the model the data that whether the alarm should go off or not. Sensors are binary valued. Okay, okay, sensor readings are transmitted to central decision unit. The central decision unit is our model. Okay, decision unit generate a binary output Y. So Y is also binary whether the alarm should go off or not. Okay, alarm logic is based on, so this is the logic whether the alarm should go off. If all the sensors say it should go off, then, no, if all the sensors say it is greater than some value, okay, the sum of them, okay, then it should go off, otherwise not. During system testing, it is observed that triggering an alarm when only one sensor is active leads to frequent false positive. Okay, okay, so what they say is that, so while testing, it was found that uh, if you do if you give false, if you like trigger the alarm, means the Y equals to 1, if only one of them is positive, okay, that leads to false positives. Okay, means it should not be like that. Okay, so if one of them is positive, what does it mean? That the sum will be equal to 1. So x1 plus x2 plus x3 plus x4 equals to 1, right? If one of them is 1, if one of them goes off, it's only one of them, others are guaranteed to be 0. So what we get the idea is that the theta has to be greater than 1, right? Otherwise what will happen, the alarm will go off at this situation, right? So it has to be avoided. If it is greater than 1, then this alarm will not go off, so we will not have false positive. Okay, now on the other hand, requiring all sensors to be active before triggering an alarm delays response time and risks missing genuine intrusion event. So if all of these have happened, so what might happen is that you might miss the possibility. Okay, the alarm may not go off while the intruder has already entered. Okay, so theta cannot be greater than equal to, it has to be greater than 1. Okay, and less than 4, right? After rest you can do. Okay, so you have to understand these statements, and actually you can see the problem will be solved quite easily actually. See, I took the two statements seriously, so I got something for theta. Okay, rest sentence also will give you the answer actually. If I do it completely, then it will be solved. Okay, okay, so you can see the logic how
Okay, sir.
this will
Understood.
happen. Okay.
So one more question. If you don't mind, may I present my screen so that you can see that material?
Sure. You can present. Anybody is presenting?
Can you see my screen? If you don't mind, show my screen. Can you see?
Yes.
Okay. Now can you see this page?
Yes.
Okay, sir. So in that last lecture, maybe proof one, in
Mm-hmm.
that there it said that this delta, it's equal to minimum of W star Pi, but we actually don't know the value of W star. Then how did we assume it that it's equal to or maybe less than? So,
Delta is just
hello.
so this is a
Okay.
optimization means what they are calculating the lower bound actually. Hmm. And this is a approximation they have done. Okay. So equality, as you can see, holds at W star dot pi. So they take the minimum of every. So W star pi is a vector, of course. Means all the for all the pi you can have different W star pi. They take the minimum of that. Okay, and that will result in a lower bound, right? So that is what they have done. Okay.
But
I
aren't I
I have not seen the lecture, so I don't know the context. You can tell me the context.
context is that it's just converging that from one side to second side it's going like that line is changing just from lower one. What can I say that fourth or no third phase, from third phase to first phase it's going like that, and it's called converging from this side to that W star. We don't know W star, but we are thinking that it exists as it said in there. You see that in observation they have said it's just saying that we don't know what it is, but it exists.
Okay, okay, okay.
So here I am little bit confused that if we don't know that value, so how can we assume regarding this?
See, the minimum is taken over the parameter I, which is of P, not W star. What is P here? Pi?
PI is that point. It's where we were using right that X thing, X1, X2, X3.
Okay. So
Uh,
it takes the point such that
Difference is
the
using P points.
it takes the Pi such that the minima, the product is minimum. Understood?
Hmm.
That is what it is doing. And if say if you have to understand W star is fixed for everyone of the Pi, so it only depends on Pi. That is what I understand.
But sir, maybe my understanding is little bit low, but and that W star is not found or we don't know what its value. So how would we decide that?
But we are not deciding on W star, we are deciding on Pi, right?
It's a multiplication, right?
But W star is
Maybe
fixed
dot
for
product.
W star is fixed for all of them, right? Only the varying factor is
Uh,
I, which is
huh.
part of Pi.
Hmm.
Correct?
Maybe you are correct, but I still didn't understand.
See the W star multiplied P1, W star multiplied P2, W star multiplied P3. So W star is not a deciding factor. It is same in all of them, right? Only the Pi is deciding factor.
Hmm. So are you saying that PI that we have already normalized in that page, so it's changing the values of W star as well,
Pi,
or maybe minimizing?
what you're saying?
I'm saying that in here right there, it said that w delta is equal to minima of w star dot pi for all I. Then maybe we are just normalizing the values. Is it like that?
Saying no, no, it's not like that. It is just that W star. So you have different for I goes to 1 2 3 4 like that. P will be like pi p1 p2 p3 p4 like so. W star is fixed for all of them. Okay, only the pi is fixed. Okay, the minimum will be the minimum pi. Okay, does not depend on W star. Okay, that is simple enough.
But here it says no that dot product. Why aren't we considering
Dot
this
product.
here?
Okay. So even in dot
You see,
product,
uh,
so in dot product, if you say, so the magnitude and the angle between them, right? Pi, I don't think pi is a vector here. Is it a vector? I don't think it's a
no,
vector.
no, no. It's a scalar only.
So then the dot product is not a dot product. It is a multiplication. A scalar multiplied to a vector w star.
Hmm. Alright. Yeah, yeah, I understood, understood. It's just regarding the direction, not considering the values. Okay, okay, understood. Okay, sir. That's it. Thank you, sir.
Okay, thank you.
How to stop?
Anybody has anything else to say?
Thank you, sir.
So today's lecture was very chaotic. Sorry for that. Just some iPad problem. I restarted the iPad, then there was no trouble after that. Okay. Planning to finish off here. Anybody has any doubt? Second question, if you want to discuss of week two. Anybody wants to discuss?
So regarding gradient descent, do we need any prerequisite? Maybe I tried, but I didn't understood that one thing. So is there any
It's an
prerequisite?
optimization, unconstant optimization. You can search unconstant minimization. Then you can from the optimization book
In
you can.
week two, gradient descent regarding that
Hmm? What is it?
prerequisite for the gradient descent things.
It is an optimization concept actually. It is derived from optimization. So for that, so if you go to like Boyd, um, but it will be hard there as well. So it is basically gradient descent is that. So you have a so the gradients points towards the minima, okay, and you reduce the current value, and there's also a learning rate. So the thing is that it is guaranteed if the learning rate is low enough, it is guaranteed to go down. Okay, the value is guaranteed to reduce. Okay, so that is the basically the concept of gradient descent. If you want to go into greater details, uh, so if you go to Boyd unconstraint optimization, unconstraint minimization. So, but these are going to be hard as well, more hard than what is taught here. Okay, so these are basically the fundamentals actually, decent methods as you can see, but these are harder, even more technical. You may not need that much. Okay, so these are different decent methods, unconstraint minimization. Okay,
All right. Okay.
anything else anybody has to say? Any way to automate this one? I mean, because I have to add people, so I can just change the settings here. Some chats here. Increasing the threshold would reduce the but Increasing the threshold will reduce the noise from isolated sensors. So Heath, anything you can explain here?
No. It was that previously I sent that message, but now I got that microphone on, so it's all right. I got that answer already.
Okay, okay. So today was a little struggle. I hope you understand. It will not happen again. It's just the iPad problem I had. Restarting it solved the problem. Now, if I can add without let third party meeting access time, no. Okay, then this will work out now. Okay, thank you very much. So I'm closing. Anybody has any doubt, then we can discuss further.
So when would be the next session for this for
So
week two?
Friday, next Friday.
Okay. Okay.
Excuse me, sir.
Okay, Chitra.
Can we get the recorded video? I could not attend it because I'm a working lady. I couldn't attend it dot at 6 o'clock. I was traveling. Is there any possibility of getting the recorded
When will
video?
this one, sir?
So let me make that clear. So I'm recording, as you can see, and it will be uploaded tonight itself to my YouTube channel. So you can access from there, and also people just have this query. We need to clear it very well. So as you can see, there is problem solving session recording here. So you have to click here. So you'll get from here as well, or maybe you can subscribe to my YouTube channel. So if you click here,
So what's your YouTube channel?
yes, I will say that as well. So I'll be posting every YouTube link, and so here I'll be filling this. Okay, uh, you can access from here. It will be same actually. From you click here, and then you can from there you can take it, and to tell you the YouTube.
And sir, regarding Friday session, if we keep it on Saturday, it is good, no? Because most of us is working on Friday.
Uh, I actually had to shift to Saturday because I had some issues. I don't think I can do it every single time because they have told just one time they allow. So they did allow, but otherwise I have to keep it on Friday only just to you can understand. Yeah. So this is my ID, and let me paste it here. So you can access from the portal as well. By the way, sharing the YouTube channel as well. Not so popular, only 92
So
members.
we can access it through NPtel dashboard, right?
Yeah, you can do that as well. That is what I show here. So you
Yeah,
can
yeah.
go to problem
Yes,
solving
sir. Yes.
session recording, and then click here. Okay, then you can get the all the links of the videos. Okay. Okay. Any other? Okay. Any other thing? Thank you, Chanchal Singh. Anything else?
Excuse me, sir. Sir, last date of assignment submitted week 2.
So the date is also written here. Week two, right? So as you can see, week two is 4th February 2026.
Both assignment submit date is same.
Both are the same date.
Yes, yes. All previous assignments also same date.
Um, okay,
Hmm.
I see that. It is what it is. I. Mm, 2026.
All right, sir.
Okay, thank you very much. So next week, Friday. So the date will be. So the date will be 30th. Okay. Okay. Anything else you might want to cover? Any doubt someone had missed out before? Anybody has any doubts? Anything else?
No, sir.
Okay, okay. Then we will close it here.
Okay, sir.